we're looking at factoring still, our learning target's still factoring polynomials, but we're looking at special products or special cases. The difference of two squares, and we need to talk about squares in general, because if you notice, the next term is a perfect square trinomial. When we're talking about a square, and this is just a side conversation that we've talked about before, but we might need to come back to it. A square, remember, is any number times itself. Okay, so you're thinking x squared, and that x could represent any type of number, whether it's 3, -4, any type of number there, that's your square. So we have what are called perfect squares. I'm going to give you a list for these, for a couple of them. You might already know these lists, but some people don't. So just, if you need this, go ahead and put it on your frame. If you don't need it, that's fine. A perfect square is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 169, 194, 225. That gets you at least up to 15 squared. But just kind of know that those are perfect squares, and those are terms that you need to look for in order to use special cases. And the reason why we use the special cases is because you could still AC factor, but you're going to get really large numbers, and you probably aren't going to know the factor list for that. Because I can tell you now, I don't always know the factor list when you do some of these big multiplication. If you had like 121 and 81, well, if you're multiplying those as your A and C, that's a big number. I wouldn't be able to do the factor list for that. Okay, so that's where those special cases come into play. So difference of two squares. So sorry, this was kind of a side note here that you might need this information to help with this. So difference of two squares is a squared minus b squared. What we're saying is that if you see only a two terms, everything that we've done so far has been 3. So just a helpful hint on this one. If it's 2 terms, it's going to be an a minus b, a plus b. Okay. What's tricky about this is knowing you got to take the square root. I would go ahead and write this on your frame, as well as the example on the right on your frame. So we'll start off with the one on the left, but know that I would prefer if you wrote the right one on your frame, just because it's got numbers, which I think will be for both terms, and I think that'll be more beneficial. So what's tricky about this is a squared minus b squared. So the a and the b, we have to square root them. So a squared is really x squared. And in order to get a alone, we have to square root both sides. So a is really x. B squared equals 64. You don't have to account for the negative. It takes care of itself. So to undo the square, we have to square root both sides. And looking at a square root, you could type that into your calculator and get a number. And that number would be 8. So I have my a and my b that I could set up my factors. And it does say factor and solve. So we have x minus 8, x plus 8. That equals 0. So now that's our factored form. You don't have to do any special methods with this. You just need to know that the factored form is already in that a minus b, a plus b. So you have x minus 8 equals 0. So therefore x equals 8. X plus 8 equals 0, which means x equals negative 8. Done. So same concept on the right side. We have 2 terms. So I know right away it's difference of 2 squares because it matches that set. So a squared in our situation is 9x squared. So again, we have to square root both sides. When we take that square root, the square root of 9 is 3. X squared and the square root cancel, so it's just x. B squared is 25y squared. Once again, square root both sides. When you square root both sides, you get b equals 5y. And you set up your factor list. This one's actually kind of a little bit of a typo. You cannot solve this because you have two variables. But I'm more concerned that you know the factorization. I think the solving part, we've done it enough that you guys are actually pretty experienced and you guys are actually really good at that I'm not as concerned about the solving part. I'm more concerned that you can get the factorization. So then we have a perfect square trinomial. So there's two different ones here, and it's all about the signs. So if you have a squared plus 2ab plus b squared, this ends up being a plus b squared. Now if you have a squared minus 2ab plus b squared, this ends up being a minus b squared. Now you're probably going to ask yourself, okay, Mrs. Fish, I'm not exactly sure if I'm going to know that middle term 2ab. That's fine. Here's what you're looking for. You are looking for these perfect squares. So if you see a perfect square at the beginning and at the end, you know this special case is going to apply. Okay, so that's the trick with this. If you know you have a perfect square on the front and on the end, one of these is going to apply. So you might want to make a note of that somehow. For this, I would go ahead and write down your perfect square trinomials. And it really doesn't matter. We'll go with the right one again. Like I said, it doesn't really matter in this situation. So looking at this one, I have a perfect square at the beginning and the end, because I'm going back to that perfect squares list. Okay, so, and that's how we get our a and our b, right? So a squared is the same as y squared. We square root both sides. A is y. And we'll do the same thing with the 121. When I square root both sides, b is 11. So because I have a minus sign here, I know it's the third one. Okay, so we have y minus 11 squared equals 0. Now we actually have to solve this. No, it doesn't say to, but let's go ahead and do it anyway because you guys can do it anyway. So the square, we square root it, doesn't really affect us at all because the square root and the square cancel, so we're left with y minus 11 equals 0. Add the 11 over, y equals 11. So again, didn't ask us to solve, but we're going to be extra. Now on the right side, same concept applies. A squared, actually first off, we need to move the 4 over. And we have to move the 4 over because everything has to equal 0. All right, now we can go through. I can see here I have a perfect square with the 25 and the 4. So I'm going to go ahead and apply this. So I have a squared equals 25x squared, square root both sides, a is 5x. B squared is 4, b is 2. Because this is a plus plus, I'm going to use that a plus b squared. So a is 5x, b is 2, it's squared, set it equal to 0. Final answer. If you were to go through and actually solve this, which I'm not going to go through the steps, but if you were to go through this, you'd get negative 2 over 5. Looking at example 3 here, the area of a square coaster can be represented by d squared plus 8d plus 16. Write an expression that represents the side length of the coaster. So I have a perfect square here and here. I'm going to square root both of those to get my a and my b. A is really d, b is 4. I have a plus plus, so I know it's d plus 4 squared. So technically, this is the area. So the side length alone is d plus 4. And then write an expression for the perimeter of a coaster. So the perimeter of a coaster, remember, and it's a square coaster, if you're looking at each side, this is really, so perimeter is 4 times side length. So our perimeter is 4 times that side length of d plus 4. And then you distribute it 4d plus 16. Okay, so this was area, this is our side length, and our perimeter is 4d plus 16. And that's just going through your factorization.